Hi, from this session onwards, we will begin upon our journey to understand about the electrical and magnetic properties of matter. These properties, commonly known as electromagnetic properties, form an important aspect of our understanding of physics. They also have a vast coverage in the curriculum. As such, I have seen students often feel intimidated at the prospect of having to go through them. However, right now I want to assure you that there is no need to do so. The approach that we will be following in understanding about electromagnetism is going to be very simple. We will begin with the very basic level. We will formulate the questions that we want to ask ourselves in simple English language, and then we will define and build a conceptual framework which helps us see through logical reasoning how different conclusions follow, and eventually what we will be seeing is that we will be able to take on even tough questions and solve them. Now, because this is a very long topic, what I thought was that it would be much use to you if we understood what is coming up next. In the sense, what are the broad themes that we are going to tackle under electromagnetism? So this particular session is dedicated specifically for that. We will have an introduction to all the broad topics that we are going to cover in our journey about understanding about electromagnetism. So where do we begin? All of electromagnetism really begins with the concept of charge. So it is the first question that we will answer when we start studying about all these things in detail. You might ask me, what is charge? Well, asking that question is like asking, what is mass? And the answer is also similar. We know that charge, like mass, is the fundamental property of any material object or of any matter. For example, when we say that a mass m is moving with a velocity so and so, what we really mean is there is an object that is moving with a velocity so and that object happens to have a mass m. Similarly, when we say that a charge q is kept at a point x1, x2 or so on, what we really mean to say is that there is a material object that is kept at a particular location, and that material object has this property charge whose magnitude is q. And it also turns out, just the way that an object, by virtue of having mass, attracts another object having another mass with a force known as gravitational force, similarly, an object, by the virtue of having charge, attracts or even repels another object having some other charge with a force, and that force is called electrical force. So, this is where it will all start with, and then if I have to tell you what is that fundamental question which we will be answering through all of our studies in electromagnetism, it is this question. Let's say we have a combination of charges with us. I will define these charges, or rather charged particles really, because charge is not something that has an independent existence, it's just a property of the matter. So let's say we have these charged particles. I'll denote them with Q1, Q2 and so on. Let's say we have n charged particles. So for a matter of convention, I'll call these charged particles as source charges. And let's say Q1 is stationary, Q2 is moving. It may be moving with a uniform velocity or maybe accelerated. Similarly, Qn might be moving or stationary like this. Then in all of electromagnetism, all that we are going to answer is simply this question, that let's say we have this arrangement of charged particles out of which some charges are stationary and the others are moving, maybe with uniform velocity or maybe with acceleration. What happens if we introduce another charge, let's say small q, and for a matter of convention, we will say that this charge is a test charge. We don't know if it's stationary or if it's moving. So the question that we are going to answer is, how do these charged particles exert force on this particular test charge particle? So this is the question that we are going to answer. Now, it may seem to you that it's a very simple question to answer really. There is this combination of charges and then there is this test charge. However, if you notice that we have to learn so many properties about charged particles if we are to answer this question. Here you see we have source charges which may be even stationary, moving with uniform velocity or accelerated. Similarly, the test charge could be stationary or moving with uniform velocity or accelerated. So what we are going to do is we will break this complex problem which seems simple to be looked at like this. However, it is really complex. What we will do is we will break this entire problem into steps and study those steps. The first step that we are going to study is the concept of electrostatics. In electrostatics, what we will do is we will observe or say that let's say all these charges, the source charge as well as the test charge, all of them are stationary. So that gives rise to one of the branches of electromagnetism known as electrostatics. So here what we will essentially do is we will study about the properties of charged particles, how they interact with each other, assuming that the source charges as well as the test charge both are stationary. So what we will observe is, first of all, we will see the Coulomb's law, which gives us an expression between the force exerted by one charge, let's say one source charge Q1, on a test charge Q. After having observed the Coulomb's law, we will study about the concept of field and potential. So essentially what we will say is, in terms of field and potential, that let's say we keep a point charge particle Q here. What will happen is this Q, whenever it is placed in a particular location, it will modify the space around it. And now if you introduce another charge particle, let's say Q1, which is kept in this particular space, then due to this modified influence or the field of influence of this source charge particle Q, this charge particle Q1, it will experience some force. So this is the concept of field or the field of influence of the stationary charge that we will study. This is known as electrostatic field. We will also study about another property of this field called the potential. And once we've understood what is a field and what is potential, we will get into the question of what happens when we apply a particular potential difference across a conducting wire. That branch of electromagnetism will be called current electricity. So in current electricity, what we will essentially deal with is we have a conductor which has a large number of free electrons in it, and then this conducting wire there is a potential difference applied at its two ends, and due to it these free electrons start moving. So it is saying these charges have produced some field, and due to the field of influence, this test charge or the free electrons in the conductor have started moving. And what we will look at here is the concept of a circuit, which is nothing but a combination of a conducting wire and other elements like the resistance, the capacitor, the inductor, and the power source. The power source is essentially something that supplies this potential difference. We will also see that this power source could produce a current which has a constant magnitude and a constant direction, in which case the power source is a battery like this, and there is this constant current that is flowing in this circuit. Or this power source could be an AC power source. We will study about alternating currents or AC currents later in our course. And in this case what happens is the magnitude of the current is varying continuously along this circuit, and also the direction of the current also changes often. So after having studied current electricity, the question that we will be answering is, what happens if we keep this really long straight conducting wire carrying current I, and then a charge particle Q1, such that this Q1 charge particle is moving in a velocity that is parallel to the direction of current flow. We will see that when this charge Q1 was kept stationary, it did not exert any force or experience any force due to the current carrying wire. However, when this charge Q1 started moving with this parallel velocity, there was a force that it felt because of this wire. So this particular force that is experienced only by moving charges and is also in a way created by moving charges in the form of current, this force is called the magnetic force. So this is going to be our next topic of study. So once we study magnetic force, wherein we will see that moving charge particles can produce another kind of field known as the magnetic field. We already saw the electrostatic field here, then we saw the magnetic field here. Once we are done with studying this, we will see that just the way moving charge particles are producing magnetic field, varying magnetic field can induce an EMF or the power source or the potential difference really, and then that potential difference can further induce the motion of current in a conducting wire in the form of induced current. This phenomena that we are going to study is called electromagnetic induction. So the way it will look really is this. Let's say, so the way it is going to work is this. Let's say we have this conducting loop and there is a magnetic field that is passing through it. Let's say now this magnetic field has started to increase or decrease in magnitude. In effect, what is happening is the total magnetic field that is passing through this loop, it is changing. We will see that this particular change in magnetic field over time, it creates a motion of free electrons in this particular conducting loop, giving us an appearance as if a current is flowing in the circuit. So after having understood all these interesting phenomena, starting from electrostatics, which is a study of charged particles that are stationary, then moving charged particles under the heading current electricity, then other properties of moving charged particles in terms of the magnetic field really, and then electromagnetic induction. You might be thinking that what is happening here is, fine, this is a very important branch of physics, but essentially the kind of questions that it is answering is either produced in labs in the form of isolated charged particles, or the devices are manufactured in industries in the form of electrical circuits. However, I would like to tell you that this field is more pervasive than this, and its applications are even more versatile. For example, the sun's rays that hit upon us every day, they carry heat wave or heat radiation. Also, they make visibility possible. We can see things because of them. So heat wave, the light wave, and when you go to a hospital, you get your X-ray done, right? So even those X-rays, you will see that all these things that are so ubiquitous are also some kind of electromagnetic waves. So after having studied all this, you will study about electromagnetic waves. I will write it as EM waves here. So what are electromagnetic waves? You will see that they are nothing but oscillating electrical and magnetic fields that are coupled with each other, and they are oscillating with respect to time. Also, this disturbance or oscillation is propagating in space. They look something like this. So this is the representation of a coupled electric and magnetic field which is oscillating at a particular position with respect to time and moving across the space. And we will see that these electromagnetic waves really explain all the properties of the light radiations that we see, or the heat waves, or the X-rays, and many other kind of waves. They are all commonly called as electromagnetic waves. So what we will do here essentially in electromagnetism is simplify this particular question that we had defined, that what happens if we have this combination of source charges having different states of motion and test charge having again variable states of motion. So we have simplified this question, or rather divided it into subparts. We will study about stationary charges first, and then we will start studying about motions under special conditions first, and then study about other effects of motion of charges. And then we will see that those effects have rather a reverse effect also, the magnetic field that is produced here, that magnetic field further induces motion in the charges by exerting force. And then after having studying all these, we will generalize about the electric field that we study here and the magnetic field here, and we will say that they are more pervasive than we really think right now. All the waves, like the light waves, the X-ray, or the infrared waves, or the heat waves that we will study about, they are all, in a sense, these electrical field and magnetic fields oscillation across space and time, and they look like this in a sense. So this is all we are going to study about. We will start studying about electrostatics in details first, and then move on to the other chapters. I just want to say, buckle up.